In this video, we'll discuss how to evaluate inverse trigonometric functions. In particular, we'll look at evaluating inverse trigonometric functions for common values, such as 1/2, square root of 3 over 2, and square root of 2 over 2, along with their negatives, as well as finding unknown angles in right triangles using the inverse trigonometric functions. In this example, we want to evaluate the following inverse trig values: the inverse sine of 1/2, the arcsine of negative square root 2 over 2, the inverse cosine of negative square root 3 over 2, and the arctangent of 1. In each case, we need to find an angle with the appropriate trig value as well as lying in the appropriate range. For the first one, the inverse sine of 1/2, we're looking for an angle theta whose sine value is equal to 1/2 and which lies between negative pi over 2 radians and positive pi over 2 radians. The range of angles here puts us in either the first or the fourth quadrant, and the sign being positive here tells us that we're in the first quadrant. So we need a first quadrant angle whose sine is 1/2, and from our basic study of trigonometry, we should know that such an angle in the first quadrant is pi over 3. So pi over 3 is the inverse sine of 1/2. Note that there are other angles whose sine is 1/2. For example, 5 pi over 6 is such an angle, which is in the second quadrant, but 5 pi over 6 does not satisfy this inequality here. We need our angle always, for inverse sine, to always lie between negative pi over 2 and positive pi over 2. For our second value, the arcsine of negative square root 2 over 2, we need the sine of theta to be negative square root 2 over 2, and also, as in the first part, we need this angle to lie between negative pi over 2 and pi over 2. Since our sine value here is a negative number, the negative square root 2 over 2, we're going to be looking for an angle in the fourth quadrant where sine is negative. We need, other than the negative angle in the fourth quadrant, we need an angle whose reference angle is square root 2 over 2, which we know is pi over 4. And to make the angle a negative angle in the fourth quadrant, we simply make our arcsine value a negative pi over 4. And this angle will do what we need it to do. The sine of this angle is negative square root 2 over 2. We know that because the reference angle for negative pi over 4 is pi over 4, which has a sine value of square root 2 over 2. And being in quadrant 4, this sine value would be negative. And of course, negative pi over 4 lies in our interval, negative pi over 2 to pi over 2. For our third part here, the inverse cosine of negative square root of 3 over 2, we want an angle theta whose cosine value is negative square root of 3 over 2. But we want the range here for the inverse cosine, we need our angle to lie between 0 and pi. This is because it's a different function than the inverse sine. The inverse sine always needs to be an angle between negative pi over 2 and pi over 2. The inverse cosine always needs to be an angle between 0 and pi. Now, here we have a negative cosine value, and our range 0 to pi gives us the first and second quadrant, and the cosine values are negative in quadrant 2. So we're going to need an angle in quadrant 2 whose cosine is negative square root 3 over 2. We know that cosine of pi over 6 is square root 3 over 2. So what we're looking for is an angle in quadrant 2 whose reference angle is pi over 6, and that angle is 5 pi over 6. This is the angle in quadrant 2 with a cosine value of negative square root 3 over 2, and therefore it is the value of the inverse cosine of negative square root 3 over 2. For our last part, we want the arctangent of 1. This is looking for the angle tangent theta that's equal to 1, and theta is somewhere between negative pi over 2 and positive pi over 2. We don't know a lot of tangent values, but tangent of 1 is probably an angle that we do know. we know that for pi over 4, for example, the sine and cosine are the same. Both are square root 2 over 2. And so if we divide the sine by the cosine, we'll of course get a tangent value of 1. And the angle pi over 4 is in the appropriate range, which is negative pi over 2 to pi over 2. And so the arctangent of 1 is equal to pi over 4. If you'd like to practice some of these on your own, try to evaluate the following expressions: inverse sine of negative 1/2, inverse cosine of negative 1/2, arc cosine of negative square root 2 over 2, and inverse tangent of negative 1. The correct answers will appear in just a few seconds. Notice that the inverse sine of negative 1/2 is negative pi over 6, which is a fourth quadrant angle, because the inverse sine function must be an angle between negative pi over 2 and positive pi over 2, whereas the inverse cosine of negative 1/2 is 2 pi over 3, which is in quadrant 2, and that's because the inverse cosine must be an angle between 0 and 2 pi. So even though we're looking at the inverse sine and inverse cosine of the same number, negative 1/2, we get angles in different quadrants because of the different ranges for the inverse sine and inverse cosine function. The arc cosine function of negative square root 2 over 2 is also a quadrant 2 angle, because in quadrant 2 the cosine function is negative. And the inverse tangent of negative 1 is negative pi over 4, because we're looking for an angle there between negative pi over 2 and positive pi over 2 with a tangent of negative 1, and negative pi over 4 fits the bill. In this example, we want to find the value of the angle theta in this triangle shown here. So notice that in this triangle, we have an adjacent side of length 9 and a hypotenuse of length 12. The adjacent side and the hypotenuse are parts of the cosine function. And so from the triangle, we're able to see that the cosine of theta is equal to 9 over 12, or 3/4 if we want to simplify that. So the cosine of theta is equal to 3/4. From this relation, we can then see that that theta will be the inverse cosine of 3/4. This is because theta, of course, is an acute angle, being an angle in a right triangle, and therefore it's a first quadrant angle if we think of it in terms of the unit circle, and so theta will be the inverse cosine of that value of that ratio, 3/4. At this point, this is not an angle we know off the top of our heads. We do not know an angle whose cosine is 3/4, and so we have to use a calculator to compute this. And if we compute it in radian mode, we should get approximately 0.7227. It's approximately equal to that. So this is in radians. And if we wanted the angle in degrees, we could either convert this to degrees, or we could use a calculator in degree mode, and we'd see it's approximately 41.4096 degrees. So depending on which unit you want to measure the angle in, we'd either get an angle of 0.7227 radians or 41.4096 degrees.